Question number 42. Ft equals mv minus mu. Prove that the equation is dimensionally correct. Now this equation is the equation for impulse. This is the equation for impulse. Now for us to solve this equation, solution, the first thing we have to do is to list out the dimensions of the fundamental quantities. What are the basic fundamental quantities we have? We have mass, and its dimension is m, capital letter. We have length, and its dimension is L, capital letter. Then we have time, and its dimension is T, capital letter. So have M, L, and T. These are the three basic fundamental quantities. So we list it out like this. This is the first thing we have to do in solving this problem. Now the second thing we have to do is to list out the fundamental and derived quantities in the equation. We ask ourselves, what are the fundamental and derived quantities in the equation? See the equation. Ft equals mv minus mu minus mu. Now, which ones are fundamental quantities and which ones are derived quantities? We start from this side. F force is a derived quantity. Time is fundamental quantity. Time, see time here, is part of the fundamental quantities. There are other fundamental quantities that I gave you in the other clips. Now m, mass, is a fundamental quantity. V is velocity. Velocity is a derived quantity. Check out my video on fundamental and derived quantities for more details. Derived quantity. Then m is the same as mass, which is fundamental quantity, and the second mass, or let's not just write it again, mass, fundamental quantity, and this u is initial velocity. So this v and this u, they are the same thing, they are the same quantities. Velocity, this one final velocity and this one initial velocity, so they have the same dimensions. So then u is derived quantity. Then having listed it this way, then the next thing we have to do is to find the dimension of the derived quantities. For the fundamental quantities, we are not looking for any dimension again, since their dimensions are this, m, l, and t. We are not looking for anything again. But for the derived quantities are made up of two or more fundamental quantities. So we look for the dimensions of the derived quantities. Dimensions of the derived quantities, that's the third thing we are doing. So we start with, let's write the equation again. Ft equals mv minus mu. Okay, Now let's start with force, which is a derived quantity. Start with force. We say that force F is a derived quantity, so we start with it. Now, to find the dimension of force, force is equal to ma, which is mass times by acceleration. Now, acceleration itself is a derived quantity. It is not part of the fundamental quantities. So we have to look for the dimension of acceleration. Then before we can now multiply with mass to get the quantity, the dimension of the force. So acceleration is velocity over time. Now velocity again is a derived quantity, so we pick velocity again and find its dimension. Now velocity is equal to displacement over time. Velocity is displacement over time. Now displacement is the same thing as distance, and distance is measured in length, so it is length. So it means length over time. So velocity is equal to length over time. Now since we say that acceleration is equal to velocity over time, now we use this value here to replace v, velocity here. So it becomes acceleration is equal to L over t, which is our velocity, now divided by t. Now that is this t down here, divided by time. Now we can see time over 1. Anything divided by itself is the same thing. So we have L, let me write it again here, L over t divided by t over 1. Now this, if we want to change this to multiplication, we use this one, bring it up, and bring this one down. So it becomes L over t multiplied by 1 over t. With this we can multiply and be able to solve it. So it becomes L times 1 is L divided by t times by t is t squared. T squared, t raised to power 2. No, so we have L over t raised to power 2. It is the same thing as L t raised to power minus 2. Remember in indices that 1 over a or 1 over x, 1 over x is the same thing as x raised to power minus 1. Therefore, 1 over anything raised to power 1 over x raised to power n, 1 over x raised to power n is equal to x raised to power minus n. 1 over x raised to power n is equal to x raised to power minus 1. So that is how we call this to be this L t raised to power minus 2. Because of what? This, let me write it very well. This is the same thing as L times by 1 over t raised to power 2, which is equal to L times by t raised to power minus 2, which is L t raised to power minus 2. Okay, so we have gotten the dimension for our acceleration. So, and we have that F equals F F is equal to ma. Now we know our a. We know the dimension of m because m is a fundamental quantity, so we multiply. So we have that force F is equal to the dimension of mass is m, then times by L t raised to power minus 2, which is the dimension for this here acceleration, which is now equal to m L t raised to power minus 2. Okay, now the next thing we are doing now is to go back to the equation again. F t equals mv minus mu. Now what we have is ft, not only f. So we have our f is already gotten as m l t raised to power minus 2. Therefore f, this is equal to f. Therefore ft is equal to m l t raised to power minus 2 times by t. This t is time times by time. So that is equal to, let me write it again here, m, our force ft is equal to m l t raised to power minus 2 times by t. Therefore ft is now equal to m l t raised to power minus 1. Why? T raised to power minus 2. Reason: t raised to power minus 2 times t is equal to 1 over t raised to power 2 times by t, which is equal to t over t raised to power minus 2, t raised to power 2, which is equal to t, cancel 1t here, which is equal to t raised to power, so this is equal to t raised to power t raised to power t over t raised to power 2. So this is equal to t over t raised to power 2 is equal to t over t times by 2 times by t, which is equal to this divided by this comes 1 over t raised to power 1. So which is equal to 1 over x raised to power 1 is x raised to power minus 1. So this is equal to t raised to power minus 1. So that is how we got it to be. That is how we got it to be like this. That is why the t is now t raised to power minus 1. Okay, so we are settled with ft. We have gotten ft is equal to mlt raised to power 1 minus 1. So we go to mv. mv is equal to dimension of mass is m, then times by velocity, times by dimension of velocity, that is v. Now we've gotten before that velocity is equal to velocity is what? Length over time. Velocity is length over time. So we go back, we use this length over time to replace v in the equation there, in the expression. So mv is equal to m, capital M, times by dimension for velocity is length over time, as gotten before. So that is equal to m length over time, which is equal to m l t raised to power minus 1 again. Why? This thing is the same thing as reason m l over t ml over t reason ml over t is equal to ml times by 1 over t, which is equal to m times by l over t is equal to ml times by 1 over t, which is equal to ml times by this is t raised to power minus 1. So which is equal to mlt raised to power minus 1. So we have gotten again our value for mv is equal to mlt raised to power minus 1. So we look for the value of dimension of mu. Then v and u are the same. Two of them are velocity. Just that this one is from its final velocity, while this one is initial velocity. Then mass remains the same, so the value for this thing is still the same thing as mlt raised to power minus 1. So we now have that finally that ft equals mv minus mu. The dimension of ft that I've gotten is mlt raised to power minus 1 is equal to dimension of mv is mlt raised to power minus 1, then minus mlt raised to power minus 1. Okay, so we see that this dimension is the same thing as this dimension, is the same thing as this dimension, which means that the equation is correct. We have proved that the equation is correct.